In this video, I will share some important points about a uniform motion possessed by a body. First of all, question is what is the definition of uniform motion? A body is said to have uniform motion if it covers equal distances in equal intervals of time. What is the meaning of this definition? Equal distances in equal intervals of time. What is the meaning of this definition? Suppose a body is moving along this line. If I denote position of the body by x and time at t, suppose it is starting from here. Suppose it is covering these equal distances. I am noting the time. Here time taken is suppose 0 starting time. Here I have 5 minutes, then 10 minutes, then 15 minutes, 20 minutes, and so on. If in these intervals of times which are equal, if these distances are equal, this distance is equal to this distance, time is equal, each time interval is of 5 minutes, then such a motion is said to be uniform motion. In this case, if I plot a graph of position coordinates of the body and time, then I will get a straight line graph. This is another definition of uniform motion, that we can say in uniform motion, position time graph of a body is a straight line. Now this is position time graph of a uniform motion. Now we have to find slope of this graph. Slope of position time graph. Now how to calculate slope? The method is we take any 2 points on the graph and draw perpendiculars on time axis as well as on position coordinate axis. Let us suppose here time is 0, here time is t1, here time is t2. Corresponding to time t1, suppose x coordinate is x1 and corresponding to t2, position coordinate is x2. Let me call this point as A and this point as B. If this graph makes angle theta with this time axis, with x axis, then tan of this angle is called slope of the graph. This is how we calculate slope. Now tan of angle means perpendicular over base. Let me call this point as C. In this triangle, perpendicular is BC and base is AC. Now we have to put the values of BC and AC. Let me call this distance as delta x, which is equal to x2 minus x1, and this distance as delta t, that is t2 minus t1. So BC can be replaced by delta x, AC can be replaced by delta t. So what is the meaning of delta x? It is the distance traveled in time delta t. So it is distance covered by the body divided by time taken to cover that distance. And this is nothing but definition of speed. So I can write is equal to speed. It means slope of position time graph of a uniformly moving body is nothing but speed of that body. This is how we can calculate speed of a body in uniform motion. I have just now proved that in uniform motion, speed of body is equal to slope of position time graph. Now position time graph is a straight line, so its slope is a constant. So if I plot a graph between speed of body and time, I will get a straight line. Speed is to be kept constant. So straight line will be parallel to this time axis. Now let us take any 2 points on this graph, point A and point B. Let us suppose draw perpendiculars on this time axis. Suppose foot of the perpendicular are C and D. I want to find area under this VT graph, speed time graph, from time t1 to time t2. This is the time delta t. Let me calculate area under speed time graph. Now this shaded area is a rectangle. Area of rectangle is calculated by multiplying its two sides. So I can write is equal to AB multiplied with AC. Now what is AB? AB is delta T multiplied with AC. What is AC? It is the constant value of speed. Let us suppose it is V. When I multiply speed with time, I get distance, because speed is defined as distance divided by time. Using this definition, I have written time multiplied with speed is equal to distance. So we have proved that distance covered by a body in uniform motion within some time is equal to area under speed time graph. This is speed time graph during that time. So this is another way of calculating distance covered by a body. That's all.